Artificial intelligence is essentially any device or software that perceives its environment and then takes action to reach a certain goal, whatever is determined for that goal to be. So the first area we'll look at is actually drug discovery or healthcare in general. So this is a very unique one that's been going on right now. Typically, machine learning algorithms have been used in healthcare and drug discovery previously, but usually what they've been looking at is actually how proteins may interact or the probability that it may interact with a certain molecule. Things are really changing now, though. They've been going from that kind of old AI systems to new AI systems that actually look at entire clinical information. And that's the novelty of the new algorithms, is the fact that you can actually look at the panomics of a whole system. You can look at the microbiome, you could look at the genetics, you could look at all the clinical information for a particular patient population. And these new algorithms that these companies are using can actually help determine the probability that a drug may be successful or the probability that it will be a failure. Not only can it do that, it can actually start trying to analyze the correct patient populations that will be most helped by that drug. And this is huge, especially in this kind of industry, because oftentimes it's multi-millions of dollars or billions of dollars, and it's many years to decades of work to get a drug from theory to actually commercialization. So if you can do anything that will reduce that time or actually identify a drug that wouldn't be successful to begin with, that is a paradigm shift in the way that this industry works. So obviously these kind of algorithms to help identify and actually lead the research is something that you could obviously possibly apply to NASA initiatives. The way that the old hypothesis was you had a human and they decided, all right, well, this is a kind of, I think this might work, and let's try to explore this. The way that the algorithms are being used in healthcare and pharmaceutical industry right now is they're allowing the machine or the algorithm to decide what that hypothesis should be initially to try to find data points that perhaps we cannot really identify because we can't really see the whole network altogether. This could be applied to all sorts of biologic, life propulsion, climate. It can even be worked with journal aggregation. Obviously, in all sorts of STEM types of initiatives, there's a lot of research coming out, whether it's in healthcare or in life sciences or in engineering. It's impossible for one person to learn it all or to keep up with it all. There's thousands upon thousands of journals coming out, but if you had an AI system that started aggregating all those journal articles for you and actually started pointing out, hey, these are interesting trends that we're seeing, and start seeing things before the human can actually see it, and then they decide what hypotheses or what future work is done, is one application that you could have. In telemedicine or in the clinical decision support space, there's tons of companies. You guys have seen a lot of this probably out there. Google, Amazon, Apple is opening clinics. Walmart is opening clinics. IBM Watson, the company that I work for, obviously has been doing a lot in this space, working with things like oncology and genetics and predictive diagnostic for population health metrics. Other companies getting into it involve anything that has a lot of heavy data. Imaging is a big one. You have radiology, cardiology, dermatology. Arteris is a small company that's just started and actually evaluates MRIs of the heart. So it can actually view all 4 chambers of the heart and then evaluate the cardiac output. The novelty with this is that this is something that was done by the cardiologist and can take anywhere from stated 30 to 60 minutes, and this actually can do it in about 10 to 15 seconds. So you think about your typical workflow. If there's something that you typically did that took an hour and now a machine's doing it in less than a few minutes, that changes the dynamic of what you do day to day. Eyes of Watson is something that I worked on with my colleagues, and we presented at Radiographic Society of North America, which is a big radiology conference last year. And essentially worked on a similar question-answer engine that you guys might be familiar, that got popularized in 2011. So you have the NLP, the natural language processing, that would actually evaluate the questions, and then it would actually be looking at imaging and using computer vision or machine learning, find the caveats or the interesting points within that image. We had chest x-rays, chest CTs, cardiac CTs, mammograms, and breast ultrasound, and then be able to show you what the probability of what the correct answer was. And as it digested more information, the different probabilities would change. And then we actually did like a flow diagram that actually allowed the human user understand how Watson was thinking, how the different neural networks were thinking inside the machine. Path AI was actually an initiative that came out of an imaging challenge, kind of an accelerator and incubator type of challenge, out of Harvard and Beth Israel Deaconess. And essentially they reviewed thousands of images of pathology slides that had breast cancer metastasis, and they were able to, with high accuracy, diagnose the diagnosis of metastasis in those slides. But there's other ones. Google DeepMind had an article in Nature in which they worked, I believe, with folks out of UCSF or Stanford, where they actually created a teledermatology platform. They looked at over 130,000 teledermatology slides, and they had just as good an accuracy evaluating multiple diseases as 21 dermatologists that they had on the team. Suspect sepsis is a pre-diagnosis algorithm that was created. If anyone's ever had a friend or family that suffered with sepsis, it's a terrible disorder that often happens in post-traumatic or post-surgical events. Essentially, it's a local infection that eventually becomes systemic. We get about 750,000 to 1 million cases every year. The thing with sepsis is that there's a 30% mortality. So if you get diagnosed with sepsis, it's very difficult to recover. So what some researchers set out to do is actually evaluate if they can predict the onset of sepsis before it occurred. The way they set up the neural network was they took 90 high-risk patients that had a probability of developing sepsis, and they started monitoring their blood work and all sorts of vitals for the course of their stay. And then doing that, the neural network was able to accurately diagnose, predict that patient was going to get sepsis with about 84% accuracy 1 to 4 days before they were actually diagnosed with sepsis. And then they added in 22 normals to just give a comparison, and that accuracy went from 84 to about 95% in predicting that the disease was going to happen. Wearable health technology, I don't see anybody have a Fitbit or Apple Watch? No, nobody has. Oh, a couple people, yeah. If you don't have one, then obviously you know someone that's had one. And the funny thing about wearable technology, it's been around for a long time. I remember some of the first wearable tech that came out through, and that was VC funded, happened like back in the 90s. But back then in the 90s, you had to have dial-up, so it wasn't as user-friendly, right? You could get some information, but then you had to go plug in, you had to go through the noise of the dial-up, you had to check AOL, you had to check your mail, you get on the chat board. So it wasn't really user-friendly. It's now that things are so much wireless and so easily available that it's been really taking off. And this is giving healthcare so much more data. And obviously, when you're making a machine learning algorithm, data is king. The Q is an interesting project which is using machine learning. It's based on the Kiwi AI, that's the platform that it runs on, but it uses machine learning to make smoking cessation very patient specific. So it will track you throughout your day, and it will help you set what the goals and the parameters you want to help you stop smoking, as opposed to kind of a one-stop shop with a patch or some other things. So it will help you and kind of tease you along, saying if it feels like you're about to take a smoke, it will say, hey, you can probably make another 20 minutes, or hey, you can probably make it another hour or so. So it helps you with that and targets specifically. The other interesting that they do is they actually turn into gamification. So if you're successful, you actually get Amazon credits so that you can kind of spend it later. Doc AI is kind of like having a doc in a box or a doc on your phone. Its machine learning algorithm actually uses a lot of different things. It starts out with actually taking a picture of your face, and it will make a bunch of predictions based on your face: ethnicity, race, BMI, mood, and then it asks you to input recent labs, anything else that you may have had from your doctor, and then we'll actually ask you to take pictures of your medications. If you take pictures of the medications, it will alert you when you're due for renewal of that medication if you have one, and it will automatically send it to your CVS or your pharmacy, and it will alert them and alert you that your order's already there for you to pick up. The other novel thing about this is that once it has all this information about you, the person that's using the app can actually ask questions. So it can say, do you think I'm on the right hypertensive medication? Or do you think my diabetes is controlled well enough? And it will respond. It will give you, based on your personalized medical output, what it thinks you should be doing. And then obviously you have to talk to your healthcare provider. So remote diagnosis potential applications for these type of personalized healthcare and telemedicine applications, obviously huge for crew health. International Space Station, long space duration mission, the ability to be able to do remote diagnosis, the ability to do remote treatment or specific crew health monitoring as opposed to just generic crew health monitoring are some of the potential applications that you can use this, especially when obviously you take some sort of medical officer on a deep space mission, but what if it's the medical officer that's down? Or what if there's some sort of subspecialty care that's required? There's that lapse in communication that could potentially cost lives and be catastrophic to a crew mission. So these kind of healthcare AI applications could have huge potential impacts on these kind of space duration missions.